All right, this will be a video for 7th grade. We're going to go over section 11.1. So what that's going to look like is this one, where we're going to compare data displayed in dot plots. So you will need your math book for this section. We're going to do several pages from your math book. But the stuff that we're going to talk about is we're going to talk about the data's shape, the data's center, which is something that we reviewed just yesterday in the previous section. And we're also going to talk about the spread, which is where we talk about range and outliers, which is another two things that we've talked about before. So I underlined the word median, the word range, and the word outliers, because those are vocab that we learned in section 11.0. Now, I underlined three more words under shape that are going to be sort of like new vocab words, but you probably know what at least some of these words mean, like gaps. Well, that's where there's like a big space. There's a gap in between some data. A peak, that's a high point, like a mountain peak. And then a cluster is like a close group of data. So one thing we'll look at is the shape of the data. Where is most of your data? You don't need to write these down. An image of these words will be on your homework assignment, so you can find it there if you want those notes. Where is most of your data? So if we look at this one, most of our data is in between 28 and 35, and it's pretty well spread out. Most of the data is spread out. There is a peak at 31. There's a couple small gaps, but I don't think there's enough gaps to really say there's any gaps. Maybe if it was a big gap like we have here on exercise 8, or a big gap here, or a big gap here on those three on the bottom. Are there any clusters? It doesn't look like we have any really big clusters of dots either. If we look at this fourth one down here, this is a cluster of data because, well, a cluster is a really close together group of dots. We do have some dots over here on the right of this cluster. However, this is a pretty large amount of dots here. This is another cluster. This is another cluster. Because we, like in the softball players' heights, we have 5 people who have this height, and we have 2 people who have this height. And that's almost half of our data on our softball players' height. So that is a cluster of data. When we talk about center, well, that's we're finding the median. So in order to find the median, but with using a dot plot, well, remember that each dot is a number. So we'll just cross off the lowest and the highest, the lowest and the highest, the lowest and the highest, lowest, biggest, lowest, biggest, lowest, biggest, lowest, biggest. And notice it doesn't really matter which one of these we cross off. We found our median here is 5'4". So a measure of center, what is the center of this data? It's not the middle of the graph, it's the middle dot. By crossing off the big one, little one, big one, little one. We're going to practice this a lot. The last thing is the range. So if we do the range of the data up here on the top one, we go from 35 to 28. So 35 minus 28 is 7. So our spread, this is the length from nose to thumb. What they did, this is a story problem. They were measuring from their nose to the tip of their thumb. So they ranged between 7 inches. There's 7 inches between the smallest length and the largest length. And on this one, there's no outliers. I would say there's an outlier on this bottom one, though, because most of our data is over here on the right, but we do have somebody who's played 0 video games in an hour. So anyway, let's go ahead and open up our math book. We're going to be on whatever page this is, 335, I think. On 335, we're going to talk about some of these questions. People once used body parts for measurements. So instead of using rulers, yardsticks, meter sticks, so they used to use body parts. For example, an inch was the width of a man's thumb. In the 12th century, King Henry I of England stated that a yard was the distance from his nose to his outstretched arm's thumb. Okay. The dot plot shows the different lengths in inches of the yards for students in a 7th grade class. So here's our dot plot. For one person, that was 28 inches from their nose to their thumb. For one person, that's 35 inches from their nose to their thumb. For 3 people here in the middle, we had 3 people that was 31 inches. So let's describe, for part A, describe the shape. We're going to do A, B, and C. And we'll do number 1 on the bottom too. We'll probably skip number 1. Well, A, B, and C. Well, for A, to describe the shape, these dots are pretty spread out. Do we have any gaps, peaks, clusters? And are they spread out? Are they evenly distributed or grouped on one side? Looks like they're pretty evenly distributed. So our data is evenly distributed. Well, that's barely a word. Distributed. It's hard to write with this page marker for some reason. Our data is evenly distributed. We do have a peak at 31. And I'm going to say 31 inches because that's measuring in inches. It's barely a peak though, so it would have been okay if we even left that one off. Our gaps, I don't think these are big enough gaps to even say that they're gaps. And I don't think we really have a very big cluster either. We don't have a closely knit group of data because it's kind of all evenly spread out. So I think that'll be good enough for A. For part B, describe the center. So where is the middle dot? What single dot would best represent the data? In this case, we're going to want to find the median. So I'm going to cross off the bottom and the top. Bottom, top, bottom, top. I see there's a lot, so I'm going to do 3 at a time now. 1, 2, 3. 1, 2, 3. I think it's a little faster. 1, 2, 3. 1, 2, 3. Now I'm going to go lowest, biggest. Here is our middle dot. Our median, because that's one of our centers. Remember, we had mean, median, and mode. If we use mode, it'd be 31. It's actually not that bad. But mean and median are going to be better than mode all the time because there might not even be a mode. So what single dot would best represent the data? The dot at 31 and a half. That's in between 31 and 32. Our median is 31.5 inches. And that does kind of summarize our data. Most kids are around 31.5. We had some that are much lower and some that are quite a bit bigger, but for the most part, they're all around 31 and a half. And the spread, remember when we're talking about the spread, we're looking for range and are there any outliers? So our data is spread from 28 inches to 35 inches, a range of 7. Because 35 minus 28 is 7. And we're going to also mention there are no outliers. 28 is pretty close to 29. 35 is pretty close to 34. If there was like a 46 here on the end, that's probably going to be an outlier. Or like a 13 over here on this end, way over here, that'd be an outlier. So let's go ahead and write these words on this page. Make sure you have this. We're going to go to the next page. In this example, we're going to look at these dot plots, and we're just going to visually view them. We're going to not do too much math or calculations. We're just going to look at the pictures of the data. So someone asked the heights of 15 high school basketball players and 15 high school softball players. They figured out their heights. What do we notice? So if we visually compare the shapes of these dot plots, softball, most of the data is 5'6" or less. Okay, so that's our shape. It's all less than 5'6". So we start at 5.6 and they're to the left of that. If we look at basketball players, most of our data is 5'8" and to the right. We do have some shorter basketball players, but most of our data is to the right here. So as a group, basketball players are typically taller. That's not the case for everybody. Notice we have a 5'2" basketball player, and there's like all these softball players that are taller than this person. But in general, basketball players seem to be taller than softball players. Next, we're going to look at their centers. Let me clear this out again. Their centers, the softball data, they found the median to be one of these dots here. So this is our median, one of those. We can figure it out. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 1, 1, 1. There we go. There's our median. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 1. There's our median. I did 6 on the left, 6 on the right, and then closed in on it. So at basketball, the median's around 5'8". Softball, the median's around 5'4". So this also shows that basketball players are typically taller. The most common height for softball players is 5'4", and for basketball players is 5'8". Next question. If we look at the spreads, we have how many inches from here to here? Well, this is 1 inch, 2 inch, 3 inch, 4 inch, 5 inch, 6 inch, 7 inches. That is our range. 5'6" minus 4'9" is 7 inches. From here, we're going up 10 inches because this 5'2" inches, we're going to 6 foot. This is 5'12" inches. So we're going up by 10. So 10 inches is our range here. So our basketball players are more spread out than our softball players. Let's see what our book says. Oh. In softball, the spread is 4'11" to 5'6". Oh, they didn't even tell us how many inches that is. Well, it's 7 inches. In basketball, it's 5'2" to 6. So there's a greater spread in heights for basketball players. And we're going to add a third sport here. It's called field hockey. Visually compare the dot plots of field hockey players to the dots for softball and basketball players. So let's look at our shape. We are kind of centered around 52. It's pretty evenly spaced out, but it gets kind of like lower as we go to the outside, right? So the data is centered at 5'2" inches. And we've got a couple gaps, but I don't think they're like huge gaps. I don't think we need to talk about the gaps. Clusters, we've got a few clusters, but it's pretty evenly like spaced out. I don't think we need to talk about clusters on this one either. So I think this shape's going to be probably good enough. The data is centered at 5'2". Kind of balanced on both sides at that point. It's not, well, we could say, and is evenly distributed from 5'0" inches to 5'5" inches. Okay. And there's not really a lot of wrong answers to these questions. We're just looking at it and drawing a conclusion. The center, we could definitely calculate a center here. So I'm going to get a different color. 1, 2, 3, 4. 1, 2, 3, 4. 1, 1, 1, 1, 1, 1. Here's our center. The median is 5'2" inches. And our spread, we go from 4'9" to 5'6". Inches. So 7 inch is range. The range is 7 inches. Now, if we go and compare those, that 7-inch range is the same as softball, smaller than basketball. The median height was 5'2", so that's actually less, I think, than softball, yep, and basketball players. And our data was centered at 5'2" and kind of came up to a peak at 5'2". But notice in softball and basketball, we had a very, very clear peak, one at 5'4", one at 5'8". So most of this wasn't as evenly distributed, evenly spread out as our field hockey players were. All right, next page here. We've got numerically compare the dot plots of number of hours a class of students exercises each week to the number of hours they play video games each week. So looking at the exercise hours, we have a cluster on the left. A lot of people don't exercise very much. If we look at, so our top exercise graph, the shape, there's a lot of data less than 4. Most of it's less than 4, in fact. Most of it's over here, and that's actually what our book says. Most of the data is less than 4. If we look at our video games, most people have greater than 6 hours. Okay, so that's how we can compare the shape. We're looking at where is the most of this data. These ones are like clearly obvious. This one has small numbers. This one has big numbers. Comparing the centers, that's where we'd find the medians. The median for exercise is 2.5 hours. So our median is about right here. If we did the median, we'd end up with 2 dots. I think I should do an example. 1, 2, 3, 4, 1, 2, 3, 4, 1, 1, 1, 1. And we have 2 dots. We have a dot at 2 and a dot at 3. Well, in between 2 and 3 is 2.5. So we have 2.5. For video games, it's one of these 9s. Even though there's an outlier here, which we might mention in a minute when we talk about the spread, the median is around here, and most people are around 9. So the median for video games is much higher than for exercise. And then for the range, medians, we have, we're spread out from 0 to 12. We're spread out from 0 to 14. From 0 to 12, 0 to 14. But this is kind of misleading because there's only one student who is 0 hours. Most of these kids are from 6 to 14 instead of 0 to 14. Here, we do have 2 people who are at 12, so we can't really rule this out. If this was only 1 dot, then we could probably say this is most of our data, but we've got 2 way over here, so we don't have an outlier. An outlier is like one single point that's way out off on its own. Okay. It does look like our book thinks that can be counted as an outlier. So if you do want to rule out this 12, since there is a large gap here, you could say most are in between 0 and 7. There's lots of right answers to these problems. Looking at this one, we need the median and the range, and then compare it. So this is internet usage. So our median, come on, page marker, where'd you go? There we go, median. Well, here. So this is internet usage per hour. One person uses, or internet usage in hours. One person uses internet for an hour. One person uses internet for 11 hours. I think this is over a week. 1, 2, 1, 2, 1, 1. So median is 6 hours. Most people here use internet for about 6 hours. We need the range. So we did the median. Now we need the range. It's 11. So range is 1 to 11, or 10 hours. There's 10 hours from our smallest one to our biggest one. Then compare the results to the dot plot for exercise in example 2. Well, Let's see if I can get these all on the same screen. Get rid of page marker here. Scroll up. All right. Looks like we can kind of fit them. All right, here we go. So this one, the video games is higher numbers. Most of them were above 6. The exercise was low numbers. Most were below 4. For internet usage, most of them are in between 4 and 7, or 4 and 8. So it's kind of like the shape of it is in the middle, in between our other two graphs we looked at. For B, comparing the centers, well, our center for exercise was 2.5. Our center for video games was 9. And our center for internet usage was 6. So again, it's somewhere in the middle of those other two dot plots we looked at. In our spreads of data, this one actually, you could probably rule out this 1 and this 11. Our spread here is between 4 and 8, which again is sort of in the middle of our exercise and our video games. So, oh, I just closed my camera. All right, that's gone. I'm gonna probably, let me see if I can pull that back up. It's gone. All right, I'm gonna finish this one without my camera. Looking at this, dot plots show the number of miles run per week for 2 different classes. This will be the last page we do. We're going to compare the shapes, compare the centers, compare the spreads, medians, ranges. When we're comparing shapes, we're looking for gaps, peaks, clusters. So what do we see? I see 2 clusters on this one very clearly. Class A. So here's what we'll do. We'll just say A here and B here. Okay, so A has clusters between 4 to 6 and 12 to 14, and a gap in between. We could also maybe talk about their peaks. This one actually has 2 peaks. Class B has 1 peak at 7. So B is centered around a peak of 7 miles. Compare the centers. Well, let's find the centers. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 1, 2, 1, 1. Center is at 6. A, median is 6. B, median is 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. Median is 6. All right. So they have the same center. Okay. Class B is a little more balanced out in the middle. Class A is heavy on people who don't run very much and people who do run very much. And it ends up being the same median. The spreads, so the spread of A goes from 4 miles to 14 miles. A spread of 10 miles. That's the range. And B goes from 3 miles to 9 miles. A spread of 6 miles. Our range, 9 minus 3 is 6. I think I'm going to have to clear this to go to number 4 and number 5. Number 4, we need the median. And actually, we did number 5 already on number 3. We talked about the range when we talked about the spread. So the ranges. Calculate the medians and the ranges. We already did both of those. So number 2, I gave you the answer to number 4. And number 3, I gave you the answer to number 5. For number 6, what do the medians and ranges of 2 dot plots tell you about the data? So the median is a good representation or summary of all of the data. The range tells you how spread out the data is. It tells you if they're really spread out or really close together. And if you have two medians, you can decide, well, who does more, who does less. If you have a range, you can decide, well, who's more consistent, who's less consistent. We're going to practice with some more of this stuff later on in some later sections, but for now, this is going to be good enough for me. Let me know if you have any questions. You'll have an assignment that goes along with this one too.